Hello, algebra scholars. Today we're going to be talking about piecewise functions. Now, as per usual, please make sure you have your notes or at least something to write on, something to write with, a calculator, and for today I would recommend having a ruler or at least a straight edge. We're not going to be doing any measuring, but we are going to be doing some graphing. So having a straight edge is going to be helpful for us to graph today. Now, what is a piecewise function? Now, a piecewise function is actually what we looked at in the previous video when we were talking about the intercepts, the increasing, decreasing. These graphs we were examining were actually graphs of piecewise functions. Notice that these graphs have multiple pieces to them. That's essentially what a piecewise function is. Now, our official definition says that we have a function defined by two or more equations over a specified domain. So algebraically, these are what our piecewise functions will look like. We're still going to have the f of x, but we're going to have a couple different equations that f of x equals. So here we've got f of x equals x minus 2 when x does not equal 2. It equals 3 when x equals 2. Here f of x equals x plus 2 if x is between negative 4 and positive 1. But then f of x equals negative x if x is between 1 and 5. So it's going to tell us when to use which piece of the function based on the x values we are given. So we're going to start by evaluating these piecewise functions. We're going to find out what is the corresponding y value that goes with each x value we plug in. So the first one tells us to evaluate f of 7. So it's giving us an x value of 7. Now the first thing we have to do is decide which piece of the function we're using. When x is 7, we've got to look at our domain. So here it says x equals 2. That's not this. Here it says x does not equal 2. Well, 7 is not 2. So that tells me this is the function I'm going to use. So I'm actually going to use the x minus 2 part of the function because of the domain telling us an x value of 7. So now that I know which piece, we just plug in our value. X equals 7. And I get a value of 5. So I can write that as y equals 5. Or I can write it as an ordered pair, 7, 5. Next one, evaluate f of 2. Again, I want to look back at my domains. Where do I have each x value? Well, this one says when the x value is 2, which is what we have, f of x equals 3. So we're using that second equation. That's it for this one. There's nothing to plug in. It's just saying, hey, it's just going to be 3 no matter the x value. Well, only when the x value is 2. We're going to get a y value of 3. Take a minute, pause the video, and try the next one. Look at each x value that's given. Decide where does that x value fall. Is the x value in this range or this range? Depending upon which range you find, will tell you which equation to plug into. Take a moment, pause the video, try parts A, B, and C. All right, now that you had a minute to work it out, let's see how you did. First one says f of 0. So let's see, where does 0 fall in these two ranges? 0 is between negative 4 and positive 1. So that tells me this is the equation to use. So I'll find that my value is 2. How about a value of 1? Does 1 fall in this first range or the second one? Now this one is a little tricky. We see 1 appear in both ranges. However, it's only in the second domain that x equals 1. 1 is less than or equal to x in this second set. So this second equation is the one we use. All right, last one, evaluate f of 3. Again, where does 3 fall in these two ranges? Well, 3 is between 1 and 5. 3 is greater than 1, 3 is less than 5. So again, we use this second equation. So our value is -3. Let's try some graphing. We're going to take these two equations, these two piecewise equations, and see what they look like graphically. Now I'm going to use a pencil first so that I can erase pieces of this. I'm going to draw the entire function and then erase the pieces I don't want to have. So the first thing I'm going to do is look at these two pieces separately. I'm going to say this is y equals x minus 2 and y equals 3. And I'm going to consider what do those look like if I didn't have this piecewise function. Well, the first one is in the form y equals mx plus b, where my m, my slope, is 1, and my b value is -2. So I can count 2 places down to find the b value, the y-intercept, and then I'll use my slope of 1 over 1 to count up 1 over 1 and put my dots. So there's the first piece. The second piece is y equals 3. This, if you recall, is a horizontal line. It goes straight across. It's that constant function. It doesn't go up or down. So I'm going to count up 3 places on my graph and draw my horizontal line. Now that I've got the two equations, okay, this first part is the equation part. Now I have to consider the domain. Where is each equation located? The first equation is located where x does not equal 2, meaning we have this line everywhere except the x value of 2. So I'm going to look at my x value of 2 on that line, and I'm going to erase it. And instead, I'm going to put an open circle on that part to say that I have everything below x equals 2 and everything above x equals 2, but I don't have that single value. My second equation has a domain of only x equals 2, meaning this equation is only located at that x equals 2 value. So 1, 2, here's that graph of y equals 3. I'm going to put a solid circle there, and I'm going to erase everything above x equals 2 and everything below x equals 2. So this is my piecewise function. I have that line y equals x minus 2 everywhere except x equals 2. That's the only place where I have the second function y equals 3. Let's try another one. Again, let's look at the equations first. So here's my equations. And then we'll come back and consider our domain for each. So my first equation is just the y equals x plus 2. My second equation is just the y equals -x. So graphing the first one, y equals x plus 2. My y-intercept is plus 2, so I'll put a closed circle up 2 places. And my slope is, once again, 1, so I'm going to go up 1, over 1, up 1, over 1. And I'm going to connect all of those dots. For the next equation, y equals -x, we consider this an x plus 0, since there's no constant. So that tells me my y-intercept is at the origin. And then I'm going to graph with my -1 slope. So down 1 over 1, down 1 over 1, down 1 over 1. And I'll connect my dots. Now I've got to consider my domains. Where do I have each one of these graphs? The first graph is only located when x is between -4 and +1. So I'm going to take a look at my value of -4. 1, 2, 3, 4. So here's where -4 starts. Okay. And then I'm going to go to +1. So here. So here's my x value of -4, my x value of +1. So my graph is only located between those x values. So I'm going to keep everything that's located in between those two, but I'm going to erase everything that's outside those values. So I'm going to erase everything that's bigger than +1, and I'm going to erase everything that's smaller than -4. Now I also want to consider the endpoints. Here it says it equals -4, so that's a closed circle. But it does not equal 1. It is strictly less than. So I've got to make sure I have an open circle here. So this is the first piece of my graph. Second piece, let's look at its domain. It's located between 1 and 4. So the lowest value on this graph is going to occur at an x value of 1. So here's my x value of 1. So I got to get rid of everything that's smaller than that. And I'm going to go as large as the x value of 4. So 1, 2, 3, 4. So I'm going to go right to the edge. So anything bigger than an x value of 4, we get rid of. So I'm only keeping in between those x values. So I'll erase all of this. And I'll erase this over here. And again, I want to consider my endpoints. Equal to, or a closed circle. Equal to, closed circle. So this is my piecewise function, where this arm is the first part of my piecewise function, and this arm of the graph is this piece of the piecewise function. All right, folks, the last type of problem we're going to look at is writing the equation. We have the graph. We want to know what the equation is. So basically the opposite of what we've just done here. So I'm going to take a similar tactic. I'm going to decide what are the equations for the lines first, and then decide what the domains need to be. So I'm going to look at each one here. First one I have is a horizontal line. It's going straight across. Recall that your horizontal lines are just y equal to a constant, specifically where that constant crosses the y-axis. So if this were to continue, it would hit the y-axis here at 1. Now for the middle piece, let's think y equals mx plus b. What's the y-intercept? What's the slope? Well, our slope seems to be down 1 over 1. So that's a -1 slope. And our y-intercept seems to be 2. It crosses the y-axis at 2. So here's our second piece of the graph. The last piece is again a horizontal line. If I considered how this would look if I continued, it would cross the y-axis right here. So let's count up. 1, 2, 3, 4 at a y value of 4. So our constant for the horizontal line over here is y equals 4. Now I don't write them as single equations. Since this is a piecewise function, I get rid of my y's and I write them using this big brace with an f equals all 3. Now the last thing I need to do is determine what my domains are. Where do I have each one of these values? So I need to see where these values stop and start. So I'm going to draw some vertical lines on my endpoints. So this first vertical line is at 1, 2, -3. So when I am smaller than -3, I have this first value. So I can say for that first value, so we'll call that one right here, x is less than -3. It's also a closed circle, so it can equal -3 at this point. Now for the middle piece. Let's consider what our domain is here. It's in between our two vertical lines. We already decided this one was at an x value of -3. So let's see, this one is at an x value of +2. So this piece is between the x values of -3 and +2, where it equals the +2, but does not equal the -3. Finally, let's look at the last piece of our graph. This one is only where it is larger than the +2. So we'll say x is greater than 2 for this last piece. We have an open circle on +2, so it's not an equal to. Take a minute and try this last graph. See what you can come up with for the equations. Pause the video, try it now. All right, now that you had a moment to take a look, let's see how you did. First piece, let's look at our y equals mx plus b. So if I were to continue this line, we want to see where would it go. Seems like it would cross at an y value of -1. So there's our b. Our slope, 1, looks to be down 1 over 1. All right, so a -1 slope, so -x minus 1. The next piece is horizontal, so it's just y equal a constant, specifically at 1, 2, 3, at -3. And our last piece, again, we want to see if we continue this, where is it going to cross the y-axis? This one seems to be crossing at a -2, with again a slope of -1. We want to write this as a single. So I'll get rid of all of my individual y's and write an f of x. Next, I want to see where my pieces are disjointed. So I've got a vertical line here, and I'm putting a vertical line here, since we have two different pieces here. They're connected, but they change the way they look. So I've got an x value of -2 and an x value of 1. So my first piece is smaller than the -2. It's on the left-hand side. So the domain here is x less than 2. My next piece is in between those two. So I'll say that x is between -2 and +1. And whoops, I missed my negative here. Sorry. I've got an open circle on the -2, so that's a less than. But I've got a closed circle here on the 1, so I'm going to say an equal to. Finally, the last piece is where x is bigger than 1. Now, be careful. Even though this is a closed circle, I can't have it closed in two places. It would no longer be a function if it has the same y value, or if it has two different y values at the same x value. So I can only evaluate my function in one of these at a time. So you could either have the equal to here or here, but you could not have it equal 1 in both places. Remember, a function can only have x defined at one y, so we can't plug it into two different y's. So I'm going to put it here, but you could have put it here. You could have put the line underneath you are greater than here, but not here. Okay, so one of the two, but not both. Otherwise, this will work for your function, guys. And that takes care of our lesson on piecewise functions.